Hey Math 30-2, today we're going to look at adding and subtracting rational expressions part 2, which means we're going to have different monomial and binomial denominators. So it's going to get a little more difficult, but we know how to add and subtract fractions, so we're going to be fine. In this section we're going to add and subtract rational expressions with monomial or binomial denominators that have no factor in common. So consider the subtraction of these two rational expressions. Let's write the lowest common denominator of these two rational expressions as a product of two different binomials. Well, the first denominator is x minus 5, so that's one binomial. The second denominator is x plus 1, so if I write them as a product, we're going to multiply these together. There's a product of two binomials, x minus 5 times x plus 1. So complete the work below to show that the subtraction of these two rational expressions gives us this rational expression, and it has restrictions of x can't equal -1 or +5. So here is the question. 2x plus 1 over x minus 5, subtract x minus 4 over x plus 1. We said the common denominator is x minus 5 times x plus 1, or x plus 1 times x minus 5, means the same thing. So my common denominator is x minus 5 times x plus 1. In order to make my first denominator, x minus 5, look like my common denominator of x minus 5 times x plus 1, I had to multiply it by x plus 1. Right? So that's what we did. We took x minus 5 and we multiplied it by x plus 1. That's right here. So whatever I do to my denominator, I must do to my numerator. 2x plus 1 times x plus 1. So both the numerator and the denominator get multiplied by x plus 1. That shows up in this step right here. Same thing happens to the second expression. To get my common denominator of x minus 5 times x plus 1, I must multiply this denominator by x minus 5. So whatever I do to my denominator, I should do to my numerator. So multiply my numerator by x minus 5. So that's right here, x minus 4 times x minus 5. Or it shows up right there. Okay. I have now written equivalent rational expressions in this step with a common denominator. I now want to expand these brackets. 2x times x is 2x squared, plus 2x plus 1x is 3x, and 1 times 1 is 1. Do the same thing with this set of brackets. X times x is x squared, x times minus 5 is a minus 5x, and negative 4 times x is minus 4x. So negative 5x minus 4x is minus 9x, and negative 4 times negative 5 is a positive 20. So I've multiplied those two binomials in my numerator together. I now want to eliminate the brackets. 2x squared plus 3x plus 1. To get rid of the brackets, they just fall away. But the second set of brackets must get multiplied by this negative sign to get rid of the brackets. So the negative of x squared and the negative of minus 9x makes that a plus 9x. And the negative of positive 20 makes that minus 20. And that's all over my common denominator of x minus 5 times x plus 1. Now I know someone's thinking, why don't we expand the denominator out, Mr. Zotner? Well, eventually we wanted to see if we can factor the numerator again. We always want to factor numerators and denominators to simplify at the very end of the question. We expanded these binomials right here so I can collect like terms and simplify my numerator. So if I continue that process, the 2x squared minus 1x squared is x squared, plus 3x plus 9x is a plus 12x, and 1 minus 20 is a negative 19, all over my common denominator of x minus 5, x plus 1. I would now look at my numerator and see if I could factor that numerator. If you recall from grade 10 and 11, how to factor a simple trinomial. What two numbers add to 12 multiplied to negative 19? Well, there aren't any, so that numerator can't be factored, so we can't simplify this expression any further. Look at our denominator for any non-permissible values. We've done this before, so let's state these as restrictions. The first denominator, x minus 5, that can't equal 0, so x can't equal 5. The second denominator, x plus 1 as a factor, can't equal 0, therefore x can't equal negative 1. So we look back to the top of the question. We've got the expression x squared plus 12x minus 19 over x minus 5x plus 1. Yep, same thing. And we've got these restrictions. X can't equal -1 or 5. This, we've proven that it's the same value. All right, so let's do another one. Example 1, simplify the following, stating non-permissible values as restrictions. All right, so just like we did last question, we're going to do it maybe a few couple less steps. But we're going to do the same thing. We need a common denominator of 2x and x minus 4. So the simplest way to get this common denominator is to write this as a product of these denominators. 2x times x minus 4. That's my common denominator. So how do I make 2x look like my common denominator? Well, I must multiply it by x minus 4. So I should multiply my numerator, x minus 4 times x minus 9, by the same thing. All right, so whatever I did to my denominator, I should do to my numerator. And that's what my numerator is, x minus 4 times x minus 9. Look at the second rational expression. X minus 4 gets multiplied by 2x to look like my common denominator. So I must multiply my numerator by 2x. So that numerator also gets multiplied by 2x. So that's 2x times 3x. I can now expand and combine like terms in my numerator. I will keep my denominator in that factored form of 2x times x minus 4. We're not going to expand out the denominators. So x times x is x squared. X times a minus 9 is a minus 9x. Negative 4 times x a minus 4x. And negative 4 times 9 is a plus 36. And over here, 2x times 3x is a positive 6x squared. Let's combine all the like terms. 1x squared plus 6x squared is 7x squareds. 9x negative and 4x negative gives me a negative 13x. And 36 constant terms, all over 2x times x minus 4. We've now added these two rational expressions with a common denominator. We should state any restrictions on the variables. So I look at my two factors of my denominator. That first one, 2x can't equal 0, so x cannot equal 0. The second one, x minus 4 can't equal 0, so x can't equal 4. All right, so this is a simplified rational expression. There are my restrictions. Okay. Let's look at part B. Need the common denominator of 2y plus 5 and y minus 3. Well, the way we're going to get that is simply by writing this as a product of two binomials, or 2y plus 5 times y minus 3. That's my common denominator. Multiply my two denominators together, I get a common denominator. Second step is to write these original rational expressions in equivalent form with that same common denominator. So this denominator of 2y minus 5 must get multiplied by y minus 3 to make it into the common denominator. Whatever I do to my denominator, I must do to my numerator. So y minus 3 should be multiplied by the numerator of 4. My second rational expression has a denominator of y minus 3. To make that look like my common denominator, I must multiply that by 2y plus 5. So I multiply my denominator by 2y plus 5. I should multiply my numerator by 2y plus 5. And that numerator was 1. All right. So now I can go ahead and expand out the brackets. All right. 4 times y is 4y, and 4 times negative 3 is a minus 12. In the second one, 2y plus 5 times 1, it could also be written as 1 times 2y plus 5. It doesn't really matter which way I write that order. And if I do like this, then I know that negative sign gets multiplied to the 2y. So negative 1 times 2y is a minus 2y, and negative 1 times 5 is a minus 5. All over our common denominator. We will not expand out our denominator. We're going to keep it in fully factored form. Now I can combine like terms of my numerator. 4y minus 2y is 2y. Negative 12 minus 5 is a minus 17. All over that common denominator of 2y plus 5 times y minus 3. I can't simplify that anymore. I now want to state non-permissible values. So I look at my first denominator as a factor, 2y plus 5. That can't equal 0. So y can't equal minus 5 and divide by 2. And the second non-differential value, you look at your second denominator, that's a factor of y minus 3, and we would say y minus 3 can't equal 0, or y can't equal positive 3. So we've simplified our rational expression. We've stated our non-permissible values as restrictions. All right, let's look at a couple more denominators with common factors. So a little more complicated now, but not much. In this section, we're going to add and subtract rational expressions where the denominators are different, but they do have a common monomial or a common binomial factor. So in this case, it's important to factor the denominators. Factor the denominators in the rational expressions before you begin adding and subtracting. So we've already done some factoring in previous lessons. If we consider this addition, 4 over p squared minus 1, add 2 over p plus 1, we want to show that it's going to turn out to be 2 over p minus 1 with restrictions of p can't equal plus or minus 1. So they've got the work started for us. So let's try it. 4 over p squared minus 1, add 2 over p plus 1. The first thing they did was factor p squared minus 1 as conjugate binomials, p minus 1 times p plus 1. All right. Once I'm at that step, I'm now going to get a common denominator of p minus 1, p plus 1, and p plus 1. So the common denominator would be p minus 1 times p plus 1. That's my common denominator. So my first denominator already looks like that, so I keep the 4 there. My second denominator must get multiplied by p minus 1 to make it look like my common denominator. So I should multiply my numerator 2 by p minus 1. So it's going to be add 2 times p minus 1. So I've now written equivalent rational expressions with the same common denominator. So I'm going to expand that out in my numerator and collect like terms. So 4 add 2 times p is 2p, and 2 times negative 1 is a minus 2. All over my common denominator of p plus 1, p minus 1. And now I combine like terms my numerator. 4 minus 2 is 2 plus 2p all over p minus 1, p plus 1. All right, so I'm done simplifying my numerator. I want to state some non-permissible values. I notice my first factor of my denominator is p minus 1. So p minus 1 can't equal 0, so p can't equal positive 1. The second factor of my denominator is p plus 1. So p plus 1 can't equal 0, so p can't equal negative 1 either. So p can't equal plus or minus 1. All right. P can't equal plus or minus 1 are my restrictions. And now I should see if I can simplify this rational expression any further. I notice my numerator has a common factor of 2. So I divide both terms by 2 and I get 1 plus p all over p minus 1 times p plus 1. So I can reduce any complete factor in my numerator, 1 plus p, with any complete factor in my denominator, p plus 1. They're the same thing. If I divide the same thing by itself, I'm left with 1. So the simplest form would be 2 times 1, which is 2 over p minus 1 times 1, which is p minus 1. That was the original solution we're supposed to have, 2 over p minus 1, restrictions of p can't equal plus or minus 1. So that's how they get there. All right. Now it says here we can do questions. We're going to do example 2. Sorry. Example 2. Notice that in the previous example, the numerator of that answer had a factor in common with the denominator. This resulted in a further reduction, which simplified the answer. We must always check to make sure our answers are in fully reduced form. That means if the numerator and denominator have a common factor, we should reduce them. But they have to have a common factor. All right. Example 2. Perform the indicated operations. Express final answers in lowest terms and indicate the non-permissible values. So step 1 will always be to factor our denominators. So my first expression, 4 over 5x plus 5, should be written as 4 over, take out the common factor of 5, I'm left with x plus 1. We're going to add to that 3 over 2x plus 2. Well, 2x plus 2 has a common factor of 2, that leaves me with x plus 1. From this step, I can now write my common denominator of these two rational expressions. The common denominator of 5 and 2 is 10, and there is still the factor of x plus 1 there. So how do I make my first rational expression, 4 over 5x plus 1, have the same common denominator as 10 times x plus 1? Well, I should multiply this whole thing by 2. So whatever I do to my denominator, I should multiply my numerator by the same thing. So 2 times my numerator of 4. Add to that, my second denominator is 2 times x plus 1. To make it look like 10 times x plus 1, I have to multiply that by 5. So I should multiply my second numerator by 5. So 5 times my second numerator of 3. Now I can go ahead and simplify my numerators. 2 times 4 is 8, add 5 times 3 is 15, all over 10 times x plus 1, and 8 plus 15 is 23 over 10 times x plus 1. Once I've simplified my numerator, I should state non-differential values. Well, 10 doesn't have a variable, so I don't have to worry about that. We only worry about the variable factors in our denominator. So x plus 1 has a non-differential value of x can't equal -1, and I can't reduce my numerator with my denominator any further. So that's simplest expression with my restrictions. All right. Let's look at part B. Step 1, let's factor our denominators. Well, 1 over x can't be reduced any further, but 1 over x squared plus 2x. X squared plus 2x has a common factor of x, so I divide both terms by x, and I get x plus 2. So I now want to state the common denominator of x and x times x plus 2. Well, there's already a common value of x there, and then I keep that common factor of x plus 2. So there's my common denominator. I now want to write equivalent fractions with that common denominator. So my first rational expression, 1 over x, I have to make this denominator look like my common denominator of x times x plus 2. So I take this x, I must multiply it by x plus 2. So if I did that to my denominator, I should do that to my numerator, x plus 2 times 1. All right, so x plus 2 times 1. Interesting. And my second common denominator, my second denominator of x times x plus 2 is already the same as my common denominator, so I don't have to do anything to my second numerator, or I can multiply it by a positive 1. All right. So I've now written equivalent rational expressions with the same common denominator. Let's simplify these. 1 times x is x, and 1 times 2 is 2, minus 1, all over x times x plus 2. If I simplify this, x plus 2 minus 1 is like saying x plus 1 over x times x plus 2. State our non-permissible values now. So I look at my variable factors, x, well that can't equal 0, and x plus 2 non-permissible value, that can't be -2. I can't reduce any common factor of my numerator with any common factor of my denominator, so that's finished. And there are our restrictions on the variables. All right. Last example then, example 3. A student was asked to simplify the rational expression and indicate the non-permissible values. Complete the work which has been started below. Looks like it's a pretty complicated one. Let's see what they did. Step 1, here's our question. Step 1, they factored the denominators. The common factor of 3x minus 9 is a 3. That leaves us x minus 3. They factor this denominator, 12 minus 4x, has a common factor of 4. Divide both terms by 4, we get 3 minus x. Now, x minus 3 and 3 minus x are almost the same if they factor out a minus 1 from the second denominator, then they get negative 3 plus x, which is the same as saying x minus 3. So x minus 3 and negative 3 plus x are the same thing. So I've got that as one common factor, and then I've got 3 and negative 4 as the numbers in front. So if I want to write down my common denominator for this expression, it's going to be 3 times negative 4 is negative 12, and x minus 3 and x minus 3, well, they're the same, so that would be my common denominator, negative 12 times x minus 3. Once I've got a common denominator, I now want to rewrite the numerators in equivalent form with that common denominator. So 3 times x minus 3, to make it look like negative 12 times x minus 3, I have to multiply that by negative 4. So I should multiply my numerator by negative 4 as well. Alright, so that numerator gets multiplied by negative 4. And to that, we're going to add negative 4 times x minus 3 to look like negative 12 times x minus 3. That must get multiplied by 3. So I multiply my numerator by 3. Alright. So I've now written equivalent rational expressions with a common denominator. I want to simplify my numerators and keep that denominator the same. So the denominator is not going to change. Negative 12 times x minus 3. My numerator, expand it and collect like terms. So negative 4 times 2x and minus 8x. And 3 times x plus 5 gives me a positive 3x, and 3 times 5 is a plus 15. Combine like terms, negative 8x plus 3x and minus 5x plus 15 all over negative 12 times x minus 3. I've now written equivalent rational expression. I could state my non-permissible values now. Alright. X minus 3 is my only variable factor, so x can't equal positive 3. And now I would see if I can simplify this rational expression. Well, I notice my numerator's got a common factor of 5, or maybe even negative 5. So maybe I'll take out the common factor of negative 5. Negative 5x divided by negative 5 is 1x, and 15 divided by negative 5 is a minus 3. So that's my numerator in factored form. My denominator in factored form is negative 12 times x minus 3. So if I want to simplify this, a negative divided by negative is a positive. 5 over 12 can't be reduced, but x minus 3 divided by x minus 3 leaves me 1 over 1. So my rational expression in lowest terms is 5 over x plus 12, and my non-permissible value is x can't equal 3. Notice I found my restriction before I reduced my fraction, so I didn't lose my variable term. Alright, so that's about as difficult as it gets to make sure we can do one like that. Let's go ahead and look at a question that might make us do all that. Let's go to page 453 and let's look at question 5D on page 453. So let's get there. Page 453, 5D. This will be the last one we're going to do. question 5, if you read it from the previous page, says simplify the following, state the non-permissible values as restrictions on the variable. So exactly what we've been doing. So I'm looking at D. Step 1, anytime you have a question like this, look at your denominator and see if you can factor your denominator. So I've got my numerator of 3, 25 minus a squared. I can factor that denominator as a difference of squares. 5 plus a times 5 minus a. And from that we're going to subtract a plus 5 over, let's see if I can factor the second denominator of 2a minus 5. Well, yeah, I take out a common factor of 2, and that leaves a minus 5. All right. So if I look closely at this, I now have to write the common denominator of this statement. So 5 plus a and 5 minus a. A minus 5 looks a lot like 5 minus a. So what I might want to do is try and get those two to be the same thing. All right. So I'm going to keep this expression the same, 3 over 5 plus a times 5 minus a plus 5 over, if I factor out a negative sign now, that would change a minus 5 to 5 minus a. Alright, so I take out this negative sign, divide both these terms by negative 1, and I get 5 minus a. What that did for me is now I've got, that's already common. So when I go to make my common denominator, I have what's already common, the 5 minus a. Alright, now I have to get the 5 plus a in there. Alright, and the minus 2. So that would be our common denominator. Negative 2 times 5 minus a times 5 plus a. That is our common denominator. What we want to do now, write equivalent rational expressions using that common denominator. So I look at this denominator, 5 plus a, 5 minus a. How do I make it look like my common denominator down here? Well, the only thing it's missing is the minus 2. So I should multiply my numerator by minus 2 because I have to multiply my denominator by minus 2. So negative 2 times my numerator of 3. From that we're going to subtract a plus 5 over negative 2 times 5 minus a. Well, to make this denominator look like my common denominator, I have to multiply that by 5 plus a. So if I'm going to multiply that by 5 plus a, my denominator, I must multiply my numerator by 5 plus a. So my numerator is a plus 5. So I've now written equivalent rational expressions using this common denominator. So let's keep that common denominator. Negative 2 times 5 minus a times 5 plus a. And let's expand out and combine like terms in my numerator. So negative 2 times 3 is a minus 6. Subtract 5 plus a times a plus 5. Well, these are really the same, a plus 5 times a plus 5. But let's expand that out and see what we get. 5 times a is 5a. Keep this all in brackets. 5 times 5 is 25. A times a is a squared. And a times 5 is 5a. All right. So combine like terms. Well, first you have to get rid of that bracket. So I've got negative 6. 5a plus 5a is 10a. So let's write this bracket in simplest form. A squared plus 10a plus 25 all over my common denominator of negative 2 times 5 minus a times 5 plus a. And now let's get rid of that bracket. So negative 6, and we're going to multiply through by the negative 1. So negative times a squared, negative times a positive 10a, and negative times a positive 25. All over my common denominator of negative 2 times 5 minus a times 5 plus a. Last step, simplify that numerator. Well, I see every term there Well, actually, let's combine like terms. Negative 6 minus 25. All right. So that's negative 31. So I got negative a squared minus 10a minus 31 all over my common denominator of negative 2 times 5 minus a times 5 plus a. All right. Well, that's the simplest form. I can't factor my numerator. I could take out a negative sign if I wanted. But I should state some non-permissible values here. So look at your variable factors in my denominator. 5 minus a can't equal 0. So a cannot equal 5. And 5 plus a can't equal 0. So a can equal negative 5. Like I said, if I wanted to, I could simplify that maybe a little bit further. Same answer if I want. That numerator could factor out a negative sign and leave that as a squared plus 10a plus 31 all over negative 2 times 5 minus a times 5 plus a. And then these negative signs could both become positive. So either form would be fine. That's one simplest form, restriction, or you could have it in this form, but they're both acceptable. All right. So you guys have questions 1 through 8 as stated in your self-evaluation. Away you go.